and we're actually located right here. The original lots of land were 277 acres, of which about 140 were mined. So the whole four dune system is still intact, so we have over a mile of beachfront, and that what we see here, which is that littoral forest, basically a coastal forest, and this is all that near shore and four dune system, and we've mined this back dune system here. So it's difficult to say how many tons of sand have been removed from here because it was started out very informally. The backstory is that the investor that purchased the land initially was looking at it for a hotel development, and it was just some strange luck that his cousin was a geologist, and then they were scoping out the site for the development. The uncle said, hey, there's a resource here that could be used, and then mining started very informally. People coming with buckets and spades and throwing it into the back of their truck, and then it has evolved to this point. So about, what was it, in 2012, unfortunately the original owner of the land had passed away, and his son inherited the project, and his son was very forward thinking and started looking at the future. We knew that the resource ultimately was going to be exhausted within the next decade, so he started thinking of what the site could do in the future. And with the advent of the national park and where we're situated in the Scotland district, and his passion for conservation and environmental sustainability, he really saw this project as a possibility of setting a benchmark for post-resource extraction. So he kind of embarked on this mission of looking at all the possibilities. So we enter a two-phased approach. So the current phase is finishing up mining. So we're in stage 5 of mining, which essentially we've exhausted everything above the groundwater table at this point. So when we go out back, it will look like there's a lot of sand still on the hill, but really this elevated section of the site is all those underlying oceanic sediments, sandstones, shales, marls, and there's a thin veneer of sand that we've left purposely on that hill to slow down water flow, so we don't continuously have erosion problems. But essentially everything above ground is now exhausted, and we've entered the last phase of mining, which is removing sand from 2 basins of water, which we call the South Lake. We can already see the edge of that lake starting to form, and it will continue back around. And then the North Lake, which we're currently operating in right now. So we expect at the demand right now that by the end of 2020 that the resource will be exhausted. It really depends on supply and demand. If a quarry or a big project comes on, we've had some years that we've moved close to 600,000 tons, which is more than all of stage 5, so things like Sandy Lane Golf Course. So looking to the future then, we've looked at a restoration project for the site that really is focused in agro-smart agriculture. So we're looking at an agroforestry project with the intent of stabilizing slopes, providing demonstrations of sustainable water use. So right now you can see areas that have been restored, and they're all in different patternings of permaculture. So we had to go through this process of experimentation where we looked at the site, different exposures. We have lots of challenges when you're planting into a quarry. We're right on the coast, so we have a lot of salt to contend with, high winds. This part of St. Andrew has very little rainfall in the dry season, so we do take a bit of a hit in the dry season. So we took a scientific approach of the whole site, and we looked at different exposure levels, different slope angles, and developed restoration patterns in those areas specific to the exposure. So in around the lakes, which has a thin freshwater lens on top of it, we use for irrigation, there's a lot of orchard style patterning. So a lot of fruit trees, stuff that you wouldn't normally see on this part, in this environment. And then on the higher, more exposed areas, we're using a lot of drought tolerant species, what traditionally the land would have been used for. So there was a lot of cashews here before, sea grapes and fat porks, so a lot of those are going back into the site. So we hope by 2022 the whole site will be restored, so all the regrading process completed and all the plantings in the ground. And then the future of the site, we're the largest private employer in the Scotland district, right, or in St Andrew right now. So with the exhaustion of sand becomes this kind of employment vacuum that needs to be filled. So we're recently opened up Wired, which is an NGO, and we've just asked, CPRI has recently joined us, which is Caribbean Permaculture Research Institute, and they're emphasizing education in climate smart agriculture. And the restoration work has been really appealing to a lot of people like yourselves, but also like grant organizations that are trying to get involved and basically use this project as a sustainable post-resource model. So we've been using drones a lot. The advent of drones has been incredible for us. We use photogrammetry for outputs like this. So this image here was taken with a drone. I think it's 3,600 photos, and we do a lot of our analysis in 3D using Civil 3D. Sand is really important on the island. Knowing where the next resource of sand is coming from is going to be paramount to making sure the economy doesn't stall.
Questions were raised on what happens when all of the sand is exhausted. The Ministry of Energy, we are commissioning a study to assess the remaining viable sand resources on the island. So there are other parts of the island similar to this property where there are potential sand resources that can be exploited. We're looking at the study to assess the volume of sand that those sites may contain, the quality of the sand, because we would want something of comparable quality, because for construction purposes you need to have certain grade of material in order to manufacture a certain quality cement and concrete and stuff like that. So we're looking at a project to do that. However, there are a number of environmental and social considerations. You don't want mining close to potential settlements and villages and stuff like that. The impacts on your environment in terms of noise, dust, a number of different things in terms of removing the vegetation, trucking things in and out, the cost of that, the cost of removing the resource. For example, they do open pit mining here. Some other areas the resource exists in hard rock, so you have to do maybe blasting, maybe crushing. That can affect the cost of the material at the end to the consumer. So we're commissioning a project to look at that. Also, we recognize that even that will have a finite life, so we have to start thinking about the potential for importation of sand. That then brings another dynamic in terms of the cost, because it has to be shipped from overseas. They need to be checked to ensure that we don't bring in any invasive species, any insects or plant species that can kill the local,
Flora and fauna,
that we have here, flora and fauna, and we have to ensure that it is of sufficient quality.
So the technology is pretty simple. It's a flying camera, but the key is the technology of photogrammetry for us. So photogrammetry essentially is creating a 3D reconstruction of a site using 2D photos. So the drone flies a route across the site as an example of a quarry, and it's taking photos on a grid pattern, and each photo is intended to overlap a certain amount. And what they then do is they basically, if this is one image and this is another image and this is another one and this is a 3D object, they basically are able in 3D space with a lot of computing power to create vectors through points of interest. So if I have a house here, corner of a house, corner of a house, and a corner of a house, they can develop points for each one of those points of interest. And the software these days does about 10,000 points of interest per photo. So very, very useful, and it's very quick. So this is a digital elevation model of the entire site, and we're able to calibrate it to mean sea level. So we have geolocations around the site, or known elevation, known coordinate basis, and within three seconds I can georeference the entire model to know exactly the elevation above sea level and scale it spatially. And then I mentioned earlier about plant health, so this is a plant health analysis. So basically it's looking at spectrums of green to understand where plants are doing well and where plants are not doing well. So obviously the lakes are looking red and the beach is looking red, and farmers use this application to check to see the success of their crops. And this really is an output that comes from it. So I have now a full 3D model of the site, and I can, look at certain features if I'd like to and get right down inside of it. So you can see here in a section that I'm doing some grading, and you can really get the perspective. And then we export all of this into GIS and to Civil 3D so we can do engineering analysis on it. So, and that's, from a resource management perspective, if this was applied, you can simply compare one year to the next year. So you can see this one was 2016, the north section of the quarry, and this was earlier this year. You can really see exactly how things change and understand all the volumes on it. The disadvantages of photogrammetry is that it will pick up tree canopies. So it's not your bare earth, it's just whatever it perceives to be the ground surface. So in mining applications it's very good because generally you're just looking at bare earth, but not all applications obviously. So as we enter here, we'll see what is stage 5 north. So the whole low-lying area of the quarry will become a lake system where we're extracting the sand from the groundwater system. The areas to our left of the bus, that slope, was last mined in the 90s. So the natural restoration is very, very slow in this environment. So you can see how long it takes. So it's very slow in restoring the vegetation. So this is, since the 90s, so over 20 years, going on 30 years. So again, this is our typical operations right now for stage 5. So we're using excavators, long boom excavators, to extract from the pond systems, and essentially we're just transporting it to the screening systems, and then the consumers are being loaded directly from this station. Our restoration program is designed to start from the back of the quarry, the furthest away from the main entrance, and work forward, so that we're essentially mining straight out of the door, and the restoration work is to follow. So no restoration work has been done largely on this side. And you can see the color of the sand that everybody knows is sand, but now that we've entered into mining below the groundwater table, you tend to get different oxidations, and that's a valid point that the consumer responds almost immediately if there's a slight change in color of the sand. So you can actually feel now what the temperature really is in the quarry. Somebody asked me why I look like Indiana Jones. It's because out here it can be really hot on a day. The radiation from the sand really escalates the temperature, but what we're noticing in some of the plantings is the more shade and cover we're putting in, that we're actually changing the microclimate, so we'll have a contrast to that in a minute. This will be the first section of the quarry that will be completed. We hope to finish this by Q3 of next year. So by the end of next year, this side of the quarry will be completely finished. So what we're looking at above us here would be the remnants of stage 4. We've already started replanting the upper sections of the quarry, and we're right now in the process of just regrading the lower sections of the quarry. There's a lot of trial and error in this. There's no written book on how to restore a quarry in this environment. So we learned the hard way that you can't regrade a section and wait 6 months to plant it, because the sand acts like a fluid and you come back and it does not look the way you left it. So we try and do the regrading almost instantly, and then plant right after that. Everything we do here is seasonally. So the dry season we tend to be focusing on plant propagation and putting some small infrastructure in place, and then the rainy season is all about putting as many plants in the ground as possible. So this whole flat lying area here will become a lake, and what we're doing right now is replanting orchard style patterning around the edges. We have lawn pond and green pond, which seasonally get an influx of migratory birds. So a lot of the conservation work that we're doing is engineering different habitats. So we're doing audits on the birds that we see year to year, and we're engineering different ecosystems for them to thrive in. The idea of engineering the ecosystem is that you want shallow and deep water habitats, and you want different varieties of nesting habitats. With the conversion of Pelican Island to the port, we lost a lot of our seabirds because there was no offshore islands for nesting. So as we go through this process, we'll be putting islands back in and hopefully encourage some of these species to stay. So right now we have fish in here that are just for mosquito control, so small fish, mollies and swordtails and things like that. But there is an intent on, after mining is completed, to actually introduce a whole ecosystem of fish for recreation, possibly fish farming, things of that nature.